I'm Alexander Wallner. I'm Senior Vice President for EMEA, so running EMEA for NetApp.
What is your job role? How do you manage the operations?
I manage the operations of the countries we do business in. It's 128 countries in EMEA, and it's very diverse, obviously. So it's Europe, Africa, Middle East, so different cultures. Very exciting.
Okay, so as a storage vendor, we see a lot of transformation happening. The workloads, the use cases, the partnerships, the actual technologies also, whether it's flash, hybrid flash, whichever, are all changing. Give us an update as to what are the alliances, partnerships, transformation happening in your product solution.
Yeah. So we see three big trends in the region as well as in general with customers, and there's different ecosystem partners for different use cases. So we see a big push in the transformation of the legacy environments. Most of our customers are not born in the cloud, so they need to drive flash adoption, they need to build data lakes. So we work very, very closely with SAP in these environments. A lot of customers need to mimic public cloud functionality in their own data center while not necessarily embracing the cloud. We have HCI. We very often use our AI partnerships like NVIDIA for these kind of things. And then we obviously have the hyperscaler partnerships with AWS, with Google, and with Microsoft Azure that are very strategic for us.
So very interesting. So I think from transformation, the last two are important. One is the hyperscaler relationship, because they allow a lot of use cases to be built up and scale up.
Correct, yeah.
And the others, of course, some of the cutting edge use cases like you mentioned with NVIDIA. So let's go one by one. So on NVIDIA and artificial intelligence and processing for artificial intelligence, what is the sort of transformation in your product portfolio?
Yeah. So we have embedded NVIDIA into our architectures. We built together with NVIDIA reference architecture that is super scalable, because the reality that we see today is that customers around artificial intelligence play around with very business critical data. So there's a huge tendency to deploy the first deployments on premise and then leverage the cloud later on. And therefore you need super scalable environments that are high performance, but you can start on a very, very low data amount level. And NVIDIA and we engage heavily on that.
So in NVIDIA, do you have specific products which you are jointly labeling as NVIDIA NetApp? And is it for specific use cases, or it's still just an open portfolio?
Yeah. It is based on our portfolio, but it is called OnTap AI, OnTap Artificial Intelligence, and it is very, very specific, built and tailor-made for artificial intelligence requirements of our customers. And it's broadly used meanwhile. It's quite successful, yeah.
Fantastic. So are the use cases for OnTap becoming visible? I mean, was there a certain demand for this sort of solution for you to bring it out?
Yeah, it is. It is obviously like it is with big data 3 years ago, so most of the customers start playing around with it. It is very, very business critical because it could bring for a lot of companies a competitive advantage compared to their competitors in the market. So being strong in AI is very strategic. It is C-level talk, and there's a high interest in the investments. We have with most of the customers these kind of dialogues. It means in different industries, different things. So different things matter in different industries. What we showcase here at GITEX is, for example, the connected bike that we have with Ducati that enables Ducati to react much, much faster than in the past on changes of where they drive, how the drivers react, and gives them a competitive advantage against their competitors. So Ducati is quite successful this year, hopefully through us.
So let's go to the hyperscalers so that we can then finish the thing. What is happening with the hyperscalers? Is it that you are giving them white label storage for them to scale out with the data centers? Is it a long-term type of supply that you need to maintain? What are the demands over there?
No, it is, we give the data management framework. So you can manage the data in the hyperscalers through OnTap, which takes the gravity of the data away. The problem with the hyperscalers is sometimes that everybody has the data in a different format, which makes it very hard to manage for the end customers. So if you have it on-premise in the same data format like off-premise with the hyperscalers, you can move the data around, you have no vendor lock in the cloud, and coming back to artificial intelligence, you can also use the hyperscalers based on their capabilities. So for example, Azure has different capabilities than AWS, than Google, who is very, very strong in AI.
So what you're saying is essentially you are like the supplier for their infrastructure as a service.
It is, I would say, the data management as a service. So what you deploy on the hyperscalers is not our hardware infrastructure, it is really our software intelligence.
Understood. So essentially the data management as a service so that they get unified hybrid performance, whether it's on-premise, public or private. That sort of model.
Exactly, absolutely.
So it's essentially licensing from you.
Yeah, absolutely. But you can also, for example, get it out of the AWS Marketplace or out of the Azure Enterprise offering. So you can do either or and really can play this ecosystem as you want as a customer.
So now globally we are seeing a lot of transformation happening in the transportation space. So whether it's the automotive or whether it is the locomotive or whether it is the aircraft, everybody's looking at making it more intelligent, right?
Yeah.
So on the vehicles, what is the sort of innovation which you are taking, whether it's motorcycle, car, or bus, anything which is happening at your end?
Maybe important to understand in that spirit is that hardware completely from the software, and the software is so lean that you can put it on every edge device, which could be everything. So obviously autonomous driving is a very, very important thing for us. We talk with every automotive company in the world about that. So really to connect all the sensor data, which is huge, which is also meaningful because of insurance reasons. Connected bike is out of the racing track, something that we have together with Ducati. But also predictive maintenance is a very important thing, like with MTU, which is a turbine producer who maintain turbines for 25, 30 years. It is very, very important to have these kind of functionalities. So all these artificial intelligence, edge device kind of connections have different meanings for different companies, but it's always very, very important.
So other than the edge, what is the full ecosystem of data transfer? So let's say tomorrow when we are doing the full AI pathway, take us from the edge to the data center to the application, how is the data going to flow? And where does NetApp accelerate the process?
Yeah. So our idea is that we are able to capture the data on the edge. So our software is on the edge device, which could be a coffee machine, which could be a bike, which could be a car. Then the idea is to transport the data in a very secure and encrypted way. You store the data wherever, on-premise or off-premise. Then you have the chance as a customer to analyze the data. And most of the customers, especially in healthcare or insurance companies, for example, also need to archive the data then. So this end-to-end process from the sensor to the archive is our description of data management.
So where does artificial intelligence or where does the machine learning or where does the intuitive acceleration come into this whole pathway?
I think from the moment you store the data, and you store it usually either on flash arrays or in a data lake, when it is in a data lake, that's the perfect moment to analyze the data, to make big data analytics or artificial intelligence learnings out of that. Because out of data lakes,
where does NVIDIA start and stop in this whole pathway? I mean, where is the actual higher compute taking place? Where is the demand on compute? Which after it comes to the data lake, or is it somewhere in between also?
No, it is basically when it is in the data lake. The complex thing with artificial intelligence is that you need almost unlimited performance. So you need really arrays that are capable of running that. Very often customers use the GPUs in the cloud, but keep data on premise. That is a functionality that we provide very, very easily. But you need unlimited performance from the CPU side and from the data side. And this makes it super complex sometimes and very demanding. But we're very happy with that. And we have good use cases also, for example, in the UK with King's College, who are a partner of the UK health system, that really help drive these kind of things.
So we're seeing some of the compute functions also changing. I was with a person who's using the glass, and I came across this term persistent memory, which means that essentially you process closer to you move the application of the data closer to the CPU. Is there any such innovation happening that you are aware of?
Yeah, it is all over the place. It even happens with legacy applications. So it is definitely a trend, and in the end, for us, the task stays the same. If you have an optimized, I would say, processor performance, but you do not provide the data in the same speed, you are pretty much in trouble as a customer. So for us, the thing doesn't change, but what you describe is an industry trend, definitely.
So can you elaborate on this in terms of use case? What you're saying is that the speed of data, the accessibility to data and the speed of compute should come closer and closer to each other. Today there is still a mismatch, right? The access to data except in flash is fast, but the rest is still a slow process, right?
Yeah, I think you don't necessarily need everything super fast. What we talk about with customers in redesigning the data centers is, with a smile in our face, we talk about flash and trash. So there's a certain part of the environment where you need low latency, high availability, high performance, and this you will store in flash arrays. For example, when you do an SAP HANA transformation, which is also an example for what you mentioned, when you do AI, then you need exactly that. But there's also a huge demand for storing the data in data lakes where performance is not business critical. You just need an ideal access to every possible data, to petabytes of data. So we always say flash and trash and build models based on that.
Okay, let's go back to the Ducati. Can you take us again through the whole thing? So the Ducati has a software sitting there as a client, right?
Exactly. Okay. So for us, a bike is an edge device, like a coffee machine. So you have a software component of us driving on the bike. You have in the pit an HCI solution that always goes on the races. And then you transport the data into the Ducati data center where you can analyze the data and feed it back in real time into the pit and into the driver.
So the data lake here would be one step ahead of that, somewhere in the engineering or R&D or where
Exactly, yeah.
So where they collect all the information from all the races, all the drivers, and then they build. I hear this term coming many times, training the data or training. What is this supposed to be?
You probably mean training the artificial intelligence algorithm. Artificial intelligence starts nowhere. So it is like a baby that comes to birth, it knows nothing, and you need to feed it. And data lakes store a lot of data, so you can ideally feed an algorithm based on the data you have and train him to self-learn, and that is exactly what happens there.
Self-learn is when the predicted outcome and the real outcome are met. What is the sort of success we are seeing from such models? I mean, predictive models, like you mentioned, predictive maintenance. It has a certain probability of error, or is it in terms of the extent of time, or what is it supposed to be?
The use cases are unlimited, I can tell you. We have customers who have drones based on artificial intelligence managing caves in the mountains to look for cheese. We have hospitals who have beds vanishing over the year, who are tracking beds now that they are not going away. The use cases are unlimited. It is a market that will go through the roof, and it will go through the roof because it's the ultimate combination of business requirements with technology. So there's a huge business requirement, and it will drive the technology.
Fantastic. So basically this innovation is happening because the success is reasonably well defined.
Absolutely, yeah. But the success means something different for every client.
Right.
And this is the reason why the uptick is relatively slow, because you cannot say we did this project here and you can map it everywhere else. And interesting enough, customers are not so openly talking about their success stories around AI. When you see the old infrastructure world, customers were super proud about what they deployed in the data center, and they talked about it. Artificial intelligence and how they deploy it and how they use it with their data scientists goes very much, I would say, to the success factors of a company. So they are not necessarily always willing to share. NVIDIA would tell you exactly the same.